Good morning, Advanced Algebra students. I hope you are having a fantastic day. We are actually finally starting in our Advanced Algebra book. So today's lesson is lesson 1.1 in Advanced Algebra, and the title is Key Features of Functions. So we did a little intro to this chapter with our last lesson on absolute value functions. And this section of the book is basically going to teach us some vocabulary and notation that we can use in describing a variety of different functions throughout the rest of this book. So it's kind of a vocabulary notation section of notes. So the first thing that we're going to talk about is what interval notation is and set builder notation. So I'm going to read a problem out loud, and then I'm going to write it in interval notation. And then I'm also going to write it in set notation. So the first problem that I'm going to read is all real numbers that are greater than or equal to 3 and less than or equal to 4. So if we are including the numbers on the end of our range, we use a square bracket like that. And that is how we would write that expression using interval notation. In set notation, we would say all real numbers such that 3 is less than or equal to x is less than or equal to 4. So again, both of these notations are ways of writing all real numbers that are greater than or equal to 3 and less than or equal to 4. Now, if I want to switch that up and not include the number 3 in my description, I could say all real numbers that are greater than 3 and less than or equal to 4. And I would write that with a curved bracket on the 3 and keep my square bracket on the 4. In set notation, I would write this as all real numbers such that 3 is less than x is less than or equal to 4. Now, let's say that we don't want to include either number on the end. So we could say all real numbers that are greater than 3 and less than 4. We could use round brackets on both the 3 and 4. And here we would say all x such that 3 is less than x is less than 4. Let's do something different here using infinity. All real numbers greater than or equal to 3. We would write a 3, comma, and then an infinity symbol. Obviously, you're always going to have a rounded parentheses with the infinity symbol because infinity is not actually a number, it's more of a concept. The way we would write this in set builder notation is all x such that x is less than or equal to, that would be all real numbers greater than or equal to 3. If we're doing greater than or equal to 3, actually we should have a square bracket there. And then 3 is less than or equal to x is less than infinity. And if I wanted to say, for example, all real numbers less than or equal to 3, I would have a negative infinity here, comma, 3. And in set builder notation, that would be all x such that negative infinity is less than x is less than or equal to, or is less than or equal to 3. Let's make that be a bracket here. So these two expressions are equivalent, but this is in interval notation. This is in set builder notation. Okay, let's look at how we could use this notation in describing a graph. So I am going to draw an absolute value function with a vertex at -2, 3. So let's have this be example 1. And we're going to draw our vertex at 2 to the left and 3 up. And then I'm going to go through the point, -1, 5, as well as the point 0 and then 2, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that would be the right-hand side of my graph, and then I would do the symmetrical branch on the left. All right, now we're going to use some vocabulary words here that are going to come up the whole rest of the chapter. The first question says to identify the domain. Okay, so domain means what? Does domain refer to x values or y, do you think? Domain refers to y. So when it says to identify the domain, you could see that x could be any number between negative infinity and positive infinity. So the domain is going to be expressed this way, between negative infinity and positive infinity. Or you could say all real numbers. Now if we want to identify the range of this function, range means the y values. So if we look at the y values, the smallest value that y can be is 3, because the vertex is at -2, 3, and it does include 3. So I would put a square bracket on 3 and put a comma and then write infinity, because y can be equal to 3 or greater than 3 all the way to infinity. Now it says identify the x-intercepts. X-intercepts means where does this graph cross the x-axis? And you can see that it does not cross the x-axis at all. So for x-intercepts, we would say none. The next question says identify the y-intercept. I just mentioned that a minute ago. The y-intercept is the point 0, 7, or you can just say 7. Now, it also asks, on what interval is the function positive? That means where is y greater than 0? So we would say that it is positive for all values. So from negative infinity to positive infinity, because the smallest value that y is 3, and it's always positive. This is very similar to one of your homework questions, so this is why I'm going over so many examples here. On what interval is the function negative? None. Y is never negative in this example. On what interval is the function increasing? So that means where are the y values going up? That is going to be on the right-hand side of this graph. So it is going to be increasing as soon as I am bigger than -2 and all the way to infinity. So we don't actually include the vertex in that description. On what interval is the function decreasing? In other words, the y values are going down. So it is decreasing from negative infinity to -2. Okay, so that would be example 1. And again, we're just going over set notation, interval notation, and some common vocabulary words that we need to be familiar with when we're talking about functions. Now let's talk about what average rate of change means. Average rate of change is basically slope. So the formula for finding the slope, and this we'll call example number 2, is f of b minus f of a over b minus a, given the interval a comma b. So let's go ahead and do a specific example. To find the average rate of change over the interval from -3 to 0 for this example, let's look at how we would calculate that. So notice that -3 is going to take us up here. At -3, our function was, the value was 5. So let me put the dot there, make that a little bit more clear. So this is the point -3, 5. on our graph there. All right, so if we want to find the average rate of change from the interval from -3 to 0, this is how we would do it. So from -3 to 0, for example 1, we would take f of A, which would be f of -3, and we would get 5. And f of B, in other words, what value is that function at B, would be f of 0. And we know the function's value at 0 is 7. So in calculating the average rate of change over that interval, we would take f of B, which is 7. So average rate of change would be 7 minus f of A, which is 5, over B minus A, so that would be 0 minus -3. 7 minus 5 is 2, 0 plus 3 is 3. So the average rate of change of this function from -3 to 0 is 2 over 3. And we can see this simply because we're going up 2 and over 1, 2, 3. All right, so that was kind of the first half of the notes. Now, let's go ahead and look at example number 3. I'm going to draw another function for you, and we're going to use some vocabulary words to describe it. So example number 3, let's draw a parabola. Now most of you have probably not graphed parabolas before, so this is going to look new. Let's put the vertex of the parabola at 3, 2, and we're going to have it have an x-intercept of 1, and then the y-intercept is at -4. And then we have another x-intercept at 5. Going that way. All right, so we're going to do the same questions that we did a minute ago for the other example to give us a little bit more practice. All right, so see if you can tell me what the domain is for this function. What is the domain for this function? The domain should still be all real numbers. If we write this using interval notation, we're going to go from -infinity to +infinity. How about the range? Remember that range means all y values. How would I write that? Using interval notation. The biggest value that y can be is 2, and it can be anything below that. So the range is going to be from -infinity to 2. Notice we have a square bracket on the 2 because we're including 2. Y can actually equal 2, but we use a curved bracket or parentheses on the -infinity. Okay, how about the x-intercepts? What would be the x-intercepts of this function? We can either say the points 1, 0, and 5, 0, or we can say 1 and 5. Identify the y-intercept. The y-intercept would be 0, 4, or we can just say 4. -4. All right, and then on what interval is the function positive? So where is y positive? The function is positive between 1 and 5. On what interval is the function negative? So here there are 2 spots where this function is negative, to the left of 1 and to the right of 5. So since we have 2 intervals, we're going to say from -infinity to 1 and from 5 to +infinity. On what interval is the function increasing? In other words, where are the y values going up if you look from left to right? Well, it is increasing from -infinity all the way up to 3. And then on what interval is the function decreasing or the y values going down? That would be from 3 to positive infinity. Okay, last example similar to the last one. What is the average rate of change over the interval 1, 3? So we want the average rate of change, over 1, 3. So this is my A, that's my B. I also need to find f of A. So what is the value of the function when A is 1? That would be 0. And f of B, what is the value of the function at 3? And the answer to that would be 2. So to use the slope formula in this case, I would take f of B minus f of A, or 2 minus 0, over B minus A, which would be 3 minus 1. That ends up being 2 over 2, or just 1. Okay, now there's a couple more vocabulary words here. Relative maximum. If you look at this parabola here, this point would be the relative maximum. If we have a parabola or an absolute value function with a vertex and the graph opens down, then that vertex is the relative maximum. A relative minimum would be like on the previous example, example number 1, where we had the absolute value function with a vertex at -2, 3, that had a relative minimum because the graph opened up. Now there's another vocabulary word that we sometimes use in place of the word intercepts. So rather than say, what are the x-intercepts of this function, I could have asked you, what are the zeros of the function? So let's just make a note here that we can ask for the zeros. If you ask for the zeros of a function, that is another way of asking what are the x-intercepts. All right, we have one last example, example number 4. So after this example, we will be done. You've done an amazing job. I'm super proud of you. I'm going to read the problem out loud, and then we will go ahead and set it up. An air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What are the domain and range of the function that represents the volume of water the air tanker can drop in seconds? Write the domain and range in interval notation. So to do this problem, you need to know that the water release rate is 400 gallons per second. The tank capacity is 8,000 gallons. And we're going to have X be the number of seconds. And I'm going to have Y be the amount of water in the tank. Amount of water in the tank. All right, so if we want to find out how much water is in the tank, we know that we're starting off with 8,000 gallons, but we know that we're losing 4,000 gallons a second, 400 gallons a second. So I would write negative 400x plus 8,000. Now, how do I know when the tank is empty? I set the amount of water left in the tank equal to 0 and solve. So I would subtract 8,000 from each side. So I have negative 8,000 equals negative 400x. Then I would divide both sides and get that x equals 20. So after 20 seconds, the tanker is, air tanker is empty. So the domain means what are the total possible values for x, or how many seconds. The domain for this problem is going to be from 0 to 20, because you can start at time of 0, but after 20 seconds, the tank will be empty, and so we would not be able to drop any more water after that. So in the context of this problem, the only relevant time we can look at is between 0 and 20 seconds. In terms of the range, that has to do with how much water is in the tank. So there can be as little as 0 gallons in the tank, or as many as 8,000. So we would go from 0 to 8,000. All right, good job, you guys. I know that was a lot of work and I appreciate it. All right, bye.